Hello friends, today we'll solve few questions by using the principle of mathematical induction. So here is the first question. Prove that 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to n is equal to 2 raised to n plus 1 minus 1. So that we have to prove. In mathematical induction we have three main steps. In the step number 1 we have induction basis. Step number 1 is called as induction basis. Step 1 it is induction basis. In this step we prove that this theorem is true for a base case. Base case means smallest value of n. In this case smallest value of n is 0. So we'll prove that this theorem is true for n equal to 0. Right? So let's substitute n equal to 0. So LHS will be equal to 2 raised to 0. We'll go till n equal to 0, that is only one term here, which is equal to 1. RHS will substitute n equal to 0 in the RHS. So 2 raised to 0 plus 1 minus 1, which is equal to 2 minus 1, which is equal to 1. So therefore LHS is equal to RHS. Therefore true theorem is true for n equal to 0. Therefore base case is true. So this was step number 1. In step number 2 it is called as induction hypothesis. Step 2 is called as induction hypothesis. In induction hypothesis we assume that the theorem is true for some value k or some number k. So assume true for some k, that is 2 raised to 0 plus 2 raised to 1 plus 2 raised to k is equal to 2 raised to k plus 1 minus 1. The theorem is true for values till k or till k. So in place of n substitute k. So this is true that we have assumed here. And step 3 is called as induction step. In induction step we prove that the theorem is true for k plus 1, right? Prove for k plus 1. So in induction hypothesis we assume that the theorem is true for k or for n equal to k. In induction step we prove that the theorem is true for k plus 1. Here we assume true for k, here we prove for k plus 1. So let's prove for k plus 1. So here what we have to prove is 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to k plus 2 raised to k plus 1 is equal to, right? In hypothesis we have assumed this, right? We have assumed that theorem is true till this term, but in induction step we have to prove that it is true also for 2 raised to k plus 1 or till 2 raised to k plus 1. So in place of n on the RHS substitute k plus 1. So 2 raised to k plus 1, in place of n substitute k plus 1. So and the plus 1, right? It was RHS was 2 raised to n plus 1 minus 1. So in place of n we substituted this. So 2 raised to k plus 1 minus 1, which is nothing but 2 raised to k plus 2 minus 1. So that we have to prove. So we have to prove that this till k plus 1 is equal to this. So let's try to prove this. So let's write the LHS. LHS is equal to 2 raised to 0 plus 2 raised to 1 plus 2 raised to k plus 2 raised to k plus 1, right? That was our LHS, which is equal to, now from induction hypothesis we know that this is equal to 2 raised to k plus 1 minus 1. So let's substitute this value here. 2 raised to k plus 1 minus 1 and this 2 raised to k plus 1. Now here we have 2 raised to k plus 1, so it will be 2 into 2 raised to k plus 1, these 2 will get added, and this minus 1. So now here we have two terms in multiplication where the base is same. When the base is same, powers get added in multiplication. So here the power is 1 and here the power is k plus 1, so that's why the power will be added, powers will be added. So 1 plus k plus 1 and this minus 1, which is nothing but 2 raised to k plus 2 minus 1, which is nothing but RHS. Right? Therefore, the theorem is true for k plus 1. That's the complete proof. In this proof, we followed three main steps. The first step is induction basis, where we proved the theorem is true for n equal to 0. In the second step, which is called as induction hypothesis, we assume that the theorem is true for k. In the third step, it is called as induction step. In this step, we prove that the theorem is true for k plus 1. While proving this step, third step, or doing third step, we take help of the assumption or hypothesis which we have in step number 2. So thank you for watching. Keep watching next video for one more example on induction hypothesis. Thank you.